When collecting data, it is important to understand which data is important and which one isn't. Actionable data, we're going to explain this now. Welcome to the show.
You know who collects the biggest amount of data annually worldwide? It's not Facebook, it's not any retail company, and it's not any evil government. It's you and me in manufacturing. We collect 2000 petabytes yearly of data. But what you need is not data, you need actionable information. And that's how to get that. That's what we are covering today in the show. But before we do that, please, if you are interested in automation or technology for electronics manufacturing, please hit the subscribe button. And if you have any question to any product in this show, please post your question in the chat. Our guests today are Stéphane Leroux.
Hey, Laszlo.
Hello. And Jérôme Rousseval.
Hello, Laszlo.
Hello, Jérôme. Jérôme, 2000 petabytes. It's a huge space on servers. What is the aim of so much data?
Well, Laszlo, collecting data means that you get knowledge and you can actually derive action from this. So, for example, in the past, people would analyze data after an event. So if you have like a problem in your factory, you would like to know why it happened, when, in which area, and how often. Nowadays, you have real-time software which can take actions. So, for example, you have software which is going to collect data as soon as it's generated. It's going to correct the processes before you have defects in the line, because it can recognize trends. And talking about trends, the industry trend today is to collect the data to prepare for potential scenarios. You want to avoid issues.
So you make predictions.
Yes.
We discussed, or I said at the beginning, you don't need data, you need actionable information. What is actionable information?
Actionable information is data where you can actually derive actions from. Mm-hmm. So if I tell you in my flat today I've got 30 degrees Celsius, it doesn't give you much information. Now if I tell you I live in Helsinki and it's the winter, you would tell me my heater system is overheating.
Mm-hmm. Absolutely. How are customers today collecting data and getting actionable information?
Well, customers are collecting data from their equipment in the factory. And because I know that you and our viewers like proper examples, I brought here a board. So it's a small board, 210 millimeters in length, times 160. But in this small area, you already have 3,400 deposits, which means from an SPI standpoint, the machine is measuring volume, height, area, offset X and Y. On this small area here, you already have 17,000 measurement data.
Only from the SPI? Only
from the SPI. So typically customers would analyze this using Excel or Minitab, but it's a very exhausting work.
Absolutely. So, and what is our solution at ASMPT? What product do we offer here?
Well, for example, I would highlight the Quality Viewer. It's a unique software tool which collects data from the complete line and which is helping customers, the engineers, to analyze, to find out the root cause of defects. And to get more detailed information, we're going to watch a video from Jason from Singapore.
Hello, and thank you for joining us today in the Singapore Center of Competence. My name is Jason, and I will be introducing ASM's open automation concept with a focus on solder-paste inspection and autonomous process optimization. Process Lens overcomes issues with typical false calls like reflections from vias, shiny pads, tracks or solder resists that are too thick and are included in the measurement. Through its innovative technology that combines 2D filtering, 3D moire measurements, and on-the-fly PCB warpage measurement and compensation, Process Lens only measures what matters, that is, the solder paste. This guarantees that any artifacts on the PCB do not create false calls that reduce operator efficiency and stop the production line. In addition to having industry-leading false call rates, Process Lens also guarantees accuracy without compromising on speed. Accuracy is crucial when we want to use inspection data from SPIs to automate process optimization. In computer science, there is a concept called garbage in, garbage out. This means that if the quality of your input, in this case the accuracy of the inspection results, is lacking, no algorithm can make up for it. And this is exactly the hurdle that many electronics manufacturers have been unable to overcome when trying to automate their print process optimization. Process Expert provides a solution to this challenge as it uses accurate inspection data from the process lens and the printing module to automatically stabilize, optimize, and proactively control. These are the three fundamentals of process optimization. The first step in the printing module is an analysis of the stencil design and printer setup, which is again completely automated using DFM Health Check software. In this way, any potential mistake during your NPI is avoided and you get it right the first time. The automation does not stop here, and during production, Process Expert takes control of the deck printer and automatically analyzes inspection data from the process lens to perform offset correction, clean rate optimization and adjustment, as well as a fractional factorial experiment that is able to change the print pressure, print speed, and stencil separation speed in order to reduce the standard deviation of your printing process. So instead of having to extract data from the SPI and analyze it using an SPC software before making changes to the process parameters on the printer, process engineers can now rely on Process Expert to automatically optimize the printing process. This automation frees up their time for more value-added activities. However, irrespective of how optimized your process is, defects may still occur, and it is crucial to be able to identify the root cause of these defects as fast as possible and take remedial actions. Currently, engineers must run from machine to machine, from the printer to the SPI and then to the placement machine in order to collect data for analysis of root causes of defects. With Process Expert's Quality Viewer module, engineers can now get process data from the whole SMT line, all displayed on one screen. The Quality Viewer module supports ASM lines, that is a deck printer, process lens SPI, and C-place placement, as well as any third-party AOI that support the CFX standard as part of our open automation concept. Through the IPC CFX standard, inter-device process data correlation is automated. That is, you do not need to worry about matching the correct ping number from the AOI to other equipment on the line. The Quality Viewer module is a root cause defect finding software across the complete SMT line, giving you a 360-degree view of processes. Based on feedback from our users, the Quality Viewer reduces the time for defect root cause analysis by up to 5 times and can lead to time savings of up to 20 hours per week. Thank you for your time, and I wish you all the best on your automation journey.
Thanks, Jason. By the way, you can download the white paper regarding to the topic of this show from our website. Jerome, we have implemented this system at many customer sites. So what is the experience of customers with this system and what is their reaction?
Well, we have different customer types. We have automotive, industrial electronics, smartphone, medical, consumer electronics as well. And the general feedback is that with the Works Experts software, customers can save up to 70% in operator interactions directly at the line. They saw a very strong reduction of the number of defects at the end of the line. So 60% reduction of the defects per million opportunities, DPMO. And they've seen as well a reduction of the time it takes process engineers, quality engineers to find out the root cause at the line with a reduction of 70%.
So I guess they were happy.
Very.
Jerome, one argument of us is less false calls with process lens. First of all, what are false calls or false accepts?
Well, a false call is a wrong measurement. Typically, from the SPI standpoint, it's when the SPI is measuring parts of the board, not really recognizing that, for example, the solder resist got thicker. Wrong measurement, false call, means that the machine stops and the operators have to come to the SPI to clear out the boards. Line stop means a loss of productivity. False accept, it's something else entirely, where a measurement machine doesn't recognize a real defect, and it's going to send the board forward down the line, which means that at the end of the line, you've got scrap or repair.
What surprises me when I visit customers is whatever the SPI tells the customer, he is just letting the PCB boards pass through. So why?
It's a very interesting observation. I've seen this as well. And actually, a lot of SPI suppliers are saying it doesn't matter how many false calls I have at the SPI stage. At the end of the line, the operator will review all the images from the AOI, from the SPI, and then will decide what to do. But for me, it's ignoring the main problem of the wrong measurement and passing it down to the line, and the amount of work which remains for the operator to do is the same. And what you have to realize is that wrong measurement means wrong data, and this translates into wrong automation and wrong prediction.
It's a very expensive conveyor system then.
Well, I don't want to be so blunt, but yes, in this case, the SPI is a very expensive system. Data is knowledge, and data has to be correct.
Thanks, Jerome. Where false calls matter are optical inspection systems, and one world-leading company in that field is the company Viscom, and I'm very glad to have Mr. Detlef Beer, Vice President and Head of Product Development with us to talk about the latest development. Hello, Detlef.
Hello, Laszlo. Thank you very much for the invitation and a big welcome from Hanover.
Detlef, you are producing SPI, AOI, but also X-ray equipment. Who needs X-ray equipment and why?
So for the post-reflow inspection in the electronic industry are more and more components with hidden solder joints common. So like components like BGAs, QFNs, DFNs. And here, to have a safe inspection, you need X-ray systems.
And X-ray equipment was so far only possible to use offline, but now you have something groundbreaking.
Yes, what you're meaning here is that mainly 3D X-ray systems have been used in the past offline, because in these cases you have for a complete PCB a test approach about 5 to 10 minutes. But with the new technology, we are now reaching cycle times between 30 to 60 seconds, and now we are compatible to the 2D X-ray systems, and this gives you a big advantage in the flexibility of the layout and testing strategy.
So the cycle time is now how much approximately?
Something between 30 to 60 seconds.
Huge improvement. Detlef, in this show we are talking about data and actionable information. What new aspects brings X-ray to this topic?
Yes, a standard way it is that the X-ray system are used to inspect the void level. This is a clear process indicator to keep then the voiding in a special range, that you have still then a good heat control, and that you don't have any heat defects later on in the running product, because these are typical long-term defects. And this is a standard and really common use. But a new approach is that you have to take care about the X-ray radiation. So we have got more and more X-ray sensitive components on the market, and you have to control the limits. Here's a big problem, that the components suppliers do not offer you any limits. So you have to define and find out your limits by yourself and by your own best practice approach.
Does that mean that these X-ray inspection limits, it locks the component in case of too much radiation or reaching the limits?
Yes, you are right. So that really means that we are building up a model. And in this case, we know the radiation for the single test of the component and also the scattered radiations from the testing of the neighbor. And all this information is saved for each ID, saved by each barcode, and this can be stored in an MES or any other places. And when you are running a retest, for example, then we are adding on. And at the end, you can define limits that as a kind of interlocking, when we see, the board has been tested a second time, perhaps, or a third time, because you have any transport issues or something else, or any retest parts, then the system say, stop, I do not infeed the board, because otherwise I will reach the radiation limits.
So it cannot be tested anymore. Another important topic when it comes to data is artificial intelligence, and optical inspection systems are primed for this technology. So what do you offer here, and what is your experience with it?
Yes, really, AI is a big topic, and also we are working since years on this topic, and we are using this in the improvement of the verifications, and also for using this as detection of voids at difficult surroundings. But I have the feeling that something wording AI is used as a kind of like a wizard. And here's really very important that you have to understand how AI is working and what are the limits of AI. So here is the main part, that always when you are talking about AI, then the result of an AI report is that you are checking here a kind of a probability. So you have a plausibility check. You get a percent values, but you don't get any measurement values. So for avoiding here, it is not usage, because when you have to define a limit of 50%, what level is okay, then no AI approach just to check this as a plausibility level is possible. That is one part. And the other thing is really that you must take care that you have really good data. Yeah? So here it's not important to have a big amount of data. Here is more important that you have a diversity of the data, and that you also have enough or balanced data where you have got good parts and defects part in a similar range.
So AI will not solve everything. In which products do you use it?
We are using this on one hand for the verification. So that is a kind of assistance for the operator, for the classifications there, to still that we can use it as an auto classification. That is one part. Or the other part is that we are using this during the testing. So using this as an additional part for segmentation, for example, for voiding for difficult surfaces.
Thanks, Detlef, and I hope to see you in one of our next shows. Thanks a lot.
Yeah, thank you very much. It was a pleasure.
Stefan, we have seen ways to collect data and get actionable information. But how about visualizing data? That's something many customers are looking for.
Yeah, it's a very good question, Laszlo. So nowadays, every manufacturing systems, every equipment in the shop floor can deliver a lot of data, but it's not only about providing this data. And so we discussed this already today. So we want to use this data to control and optimize processes. This was part of our previous discussion, but we also want to use this data to improve performance, maximize equipment and line uptime, and increase productivity. So in other words, we want to use this data to calculate and monitor KPIs, so key performance indicators. This is exactly what Performance Monitor can offer. Performance Monitor is the monitoring tool from our shop floor management suite, ISMWorks. And Performance Monitor collects data from ISM equipment in real time. This data are processed and transformed into readable KPIs that are visualized on dashboards. So it gives a first level of information to the production staff on the performance, about the performance of the line. And it's not only about visualizing the data. So APM, so ISM Performance Monitor, can also automatically notify key users. So we can set target values in the system, and when one equipment or one line is performing under this target, then key users like production managers are automatically notified when a line or an equipment is underperforming.
Out of range, yeah.
Yes, exactly.
Well, that's a lot of things it provides. I guess customers are very happy with that.
Yes, and in addition, Performance Monitor offers also history analytics on previous production orders or production shifts. And it's also a way to analyze also what has been produced in the past, yes. Yeah.
But one thing I don't understand, what is the difference to the quality viewer Jason mentioned?
So the quality viewer module from Process Expert is a tool to analyze the assembly process, including printing and placement. It is designed for process engineers who want to control the process and take corrective actions in order to optimize and improve it. Performance Monitor is a production monitoring tool that is visualizing, that is showing key performance indicators on the dashboard. So this is designed for production staff, so line operators, production managers, even plant managers who want to ensure that the lines are performing as expected and that the production targets are achieved.
So to achieve the daily quantities.
The daily quantity and yes, exactly.
So now I understand. Okay, another topic Jérôme mentioned is prediction. So let's talk about the future. I guess we are both ready, Jérôme and me. I have some lottery tickets. Please, Stefan, tell us the lottery numbers of this week.
I would love to give you these numbers, but here we're not talking about magic. So we are talking about real life, but...
So I don't understand. So what is then, how do I have to understand the prediction?
Well, we can already predict upcoming situations. With the solutions we mentioned today, Process Expert and also Performance Monitor, we can evaluate trends. We can take corrective actions on about any deviations that can occur during production before this issue could have a critical impact on the production. So we can already predict upcoming situations with these two tools. But I give you another example. So we have developed in collaboration with our sister company, Critical Manufacturing, a tool that is able to monitor the operating conditions of the equipment and manage all required maintenance activities. It is ISM Factory Equipment Center. What does this have to do with prediction? Well, with Factory Equipment Center, a maintenance engineer can monitor specific parts of a placement head, for instance, and he can schedule a repair task before this part breaks down and before it causes any further damages on the machine and it caused any unscheduled production downtime. Yeah. So in general, Factory Equipment Center is a tool that helps you manage all your maintenance tasks more efficiently, so you get better transparency on all your maintenance activities, and then you can drastically reduce line downtimes by better managing and scheduling all your maintenance activities there.
Is it possible to connect also third-party equipment?
Yes, and this is also the one big benefit of this tool is that Factory Equipment Center is a vendor-independent solution. So it supports, of course, any type of ISM equipment, but also third-party systems. Yeah.
You could also postpone a maintenance if you see that there's nothing.
Exactly, yeah. So we were talking about this monitoring of specific parts, then we can trigger any repair, a repair task. But of course, if we see that these systems are in good conditions and we can eventually postpone maintenance or schedule maintenance tasks.
Activities.
Yes. Yeah.
Fabulous. Thank you both for your expertise. As always, at the end, I have some recommendations for you. If you want to see us in real life, we are available at following shows, which you see down there in the ticker. Also, I would recommend you to, of course, subscribe to our channel and please download the white paper to this show. There are many white papers regarding to all our show topics, but there's one specifically to this topic, data and actionable information. Last but not least, in our next show, we will highlight everyday workflows in your manufacturing pimped with software. So that's all for today. Thanks, Stefan.
Thank you, Laszlo.
Thanks, Jérôme.
Thanks, Laszlo. You may come all the way from Le Mans, and I understand today I won't get rich, right?
No, unfortunately, Stefan didn't tell us the right numbers. So thanks for joining. Stay safe. And yes, stay open, first of all.